A particle moves in the xy plane so that x equals the square root of 3 minus 4 sine t and y equals 1 minus 2 sine t, where our t value is between 0 and 2 pi. The path intersects the x-axis twice, so if this was our x-axis, we know that it's going to intersect twice. It could go up and come back down, or go down and come back up. It doesn't matter for what we're talking about here. Write an expression that represents the distance traveled by the particle between the two x-intercepts. So we're talking about this distance here, which is the arc length. So we're going to be using the arc length formula, and basically the idea there is that you're looking at the velocity vectors in component form. We're looking for the magnitude of those, but then integrating to go from velocity to position to distances. So our formula is from time A to time B. So we're adding up all of our little itty bitty segments, and it is the square root of dx dt squared plus dy dt squared, and this is all with respect to t. So it's very similar to the magnitude of our velocity vector, but we're integrating it from a time to another time. So the integration is what's turning this into an actual distance. And we'll look at this again when we look at arc length in non-parametric form. So for our purposes, we know what well, we don't know, but we can find dx dt and dy dt very quickly. So that's where I would start. I'll have the square root. X equals square root of 3 minus 4 sine t. So I'm going to take the derivative, and I will get a negative 4 cosine t squared plus our dy dt is the derivative of this. So we have a negative 2 sine t. So the derivative of that will be a negative 2 cosine t squared dt. Now, conveniently, if you left the signs off, you would be okay because you're squaring both of these individually. You should end up with a positive number. The last thing you have left to do is actually figure out what are our times from A and B, and they are not from 0 to 2 pi. That's just when these equations are working. So we have to figure out the time that you have your first x-intercept and the time when you have your second x-intercept. We know x-intercepts are when y equals 0. So what we need are the times when y equals 0. So we'll go up to our y equation, which is 1 minus 2 sine t, and we will set that equal to 0 and solve for t. Our t values have to be in between 0 and 2 pi. So first thing you do is isolate the sine of t. So I know sine of t equals, and I'll subtract 1 and divide by a negative 2. So my sine of t equals a 1/2. On our unit circle, we know that the sine values are the y values, and this is a small value, so we're here and here above the x-axis. The radians for that are pi over 6 and 5 pi over 6. So those would be our limits of integration. And this would be the expression that would give us the length of the curve. We wouldn't evaluate it because it, number one, said we didn't have to. But the second thing is this would have to simplify down to something that was a perfect square, so we could take a square root to actually evaluate this by hand. Because you don't actually have anything out here to be your du if this was your u and you were trying u substitution. Most likely you would have a calculator to work this problem.